our webinar today is a fundamental discussion and a fundamental sort of, I guess, let's say, interaction about blower doors. It's useful for those of you who are new to blower door testing. It's going to be useful for those of you, I hope it's useful for those of you who are teaching or interacting with people who are new to blower door testing. Hopefully you'll find some ideas and maybe some different ways to explain it. We're going to cover a lot of material in here, I guess, so we're going to try and move very right over the top. I'm going to try and stay very superficial with the information. At the end of the week, on Fridays, we always have a chance to sort of meet with you and get deeper into the Q&A, and that will be Friday. Same time, same bat channel. We'll be doing a webinar if you have any questions that we don't get to today. So we are going to be talking about reasons to test. We're going to be talking about some of the code requirements for blower door tests. We're going to talk about how to test. We are going to talk about blower door tests and how they relate with quality control. Some ways to ensure that your tests are accurate. And then we're also going to go on and talk a little bit about common test problems and test solutions. Anybody have any questions about that? Is it okay? Great. Well, let's move on to the next one. So yeah, Mr. Sanfilippo, I see your question. We will definitely get to it. We're not going to, I'll be answering questions in the background. Today it's just me solo here presenting this material. So, but anyway, the point is that I wanted to let everybody know that we do have an online training and certification that we provide through Retrotec. It's at retrotec.com. You can sign up for it. For those of you who have bought equipment recently, hopefully you know that you can actually take it for free. If you haven't, please inquire to our salespeople or call your service rep. There is the number right there, 1-855-738-7683. It's also available. You can get people at sales.com. I'm sorry, it's sales@retrotec.com, or just go to www.retrotec.com. All the support, all the information, all the people you need are right there. But just to let you know, all this information, you don't have to just sit back and relax. All of this information is available to you via our online training and certification, and definitely far more in depth. In addition, you'll also find all this information and all of our training. It all kind of closely follows all of these quick guides and manuals that we have available to you at retrotec.com. Just check it out in the support area. It's got a nice little search window of its own. You can find sort of anything you're looking for, whether it be, you know, it's sort of an encyclopedia of knowledge as far as testing, pressure, and all of us, and definitely all the applications and products that we sell. So many of you have different, I'm sure you all have very different specific reasons to test, especially considering that you're from all over the globe. But in my mind, it kind of breaks down into two sort of basic reasons to test. One would be, you know, compliance. Trying to test to meet codes, or because you're working for a program. But then there's another this area right here. There's another reason, and another reason would be actually just doing sort of energy audits with the intent of actually sort of improving the house. So let's talk about those two sort of basic reasons, shall we? So I want to get into a little bit of detail here about the IECC. Now there are a lot of different codes. There are a lot of different programmatic specifications, but this one is the hottest topic, and judging from what you've told me about yourself so far, I picked the right slide to talk about. But just to give you a little bit of idea about what the IECC says, and this is their code, or this is what their specification is for the 2012, and that is 5 air changes per hour in climate zones 1 and 2, 3 air changes per hour in climate zone 3 and 8. It says that a code that where required by code official, testing shall be conducted by and approved at third party with a written report. So to let you know, this is what this code says. But as many of you know, I'm sure you're well aware of the fact that each state, and each municipality within that state oftentimes is allowed to interpret that differently. And obviously there's a wide variety, there's a wide sort of spectrum for interpretation. Many of you are actually more familiar with a testing system called ASTM 779. ASTM 779 is the most widely used one when we're talking about your general energy audit. So an energy audit usually takes place for kind of 3 overall reasons. One, that you want to propose some upgrades. So oftentimes when we're talking about an energy audit, we're talking about something that we do on an existing house, or so that we can ideally and possibly move on to a retrofit. So a retrofit is the idea, or is the terminology that we use for proposed upgrades. But it might also be done, an energy audit might also be done to characterize overall performance and to identify failures. And in this slide that I have right here for you, what you're seeing is the house in comparison to Swiss cheese. And that Swiss cheese is, I guess, sort of talking about some of the failures that we see, both in the shell and in the duct system. But today we're going to be talking about blower doors. So we're going to be talking about the shell. So here's a little bit more of a, I guess, more of a basic slide. So the way that a blower door test works in general, regardless of what kind of, whether you're looking for the cubic feet per minute at -50 as I'm showing here, or if you're looking for air changes per hour at -50, or whatever results you're looking for. Regardless, what you're doing is you're using that fan to either depressurize, in this picture we're just going to talk about depressurization because, again, for a 101 class it's not important to talk about pressure or depressure. The point is that we are controlling the pressure in the house via the shell that's indoors, via the fan, via a fan, and we are using a gauge connected to that fan so that we know that that house, the pressure in that house is either -50 or +50 or any other numbers. But we're going to talk about -50 right now. So let's just keep it simple. Somebody once told me, "Kiss, Jay West, keep it simple, stupid." So at -50, we are depressurizing the house, and then as you'll see that those blue arrows represent air that's coming from inside the house. The red arrows represent air that's coming from outdoors, and that outdoors air is air that we don't want. So as that air moves through, we can measure that, and we can decide how much cubic feet per minute is moving through that shell. So that's going to allow us, once again, to say there's a specific number, and since we test of CFM, or air changes per hour, but there's a specific number associated with that tells us how much air is moving through the shell of the house, how much air is coming indoors from the outdoors, and those are called bypasses. So what we do with that is we say, now that we've depressurized this house, and obviously in this schematic this house is very small, it could be, but we can compare this house to a very big, very large house because no matter what, it was all tested at -50 pascals. So now we have a test that we can do, that we can compare apples to apples, so to speak. So now we have a number of CFM, or air changes per hour, that we can compare to other people. But we can also find out where those leaks are. Does that make sense to everybody? It's probably an extended explanation that was unnecessary. So let's talk a little bit about how to actually perform a test. Again, we're going to take a really broad overview. There are a lot of details in the blower door quick guide. The blower door quick guide actually tells you how to run a blower door test, and it has all of these steps in it. In addition, we do have our online training and certification that I welcome you. In fact, I invite you to take. But first, let's talk a little bit overhead about how we would actually do it. So it's kind of a general overview. You might be surprised to know that probably the most important thing about a blower door test has nothing to do with the equipment. It has everything to do with the process. And the most important part of that process, as with most processes, is that it starts out right. And the first thing that you want to do is do a building check. You want to talk to that homeowner as part of that building check. it is absolutely essential that you make sure about some of these unforeseen things, like, are they going to be home for the whole test? Are they going to allow you to shut down the house while you set it up? Is there anybody in any areas that are sleeping? Are there any parts of the home that they don't want you to see? Believe me, take it from me, it can be very embarrassing when you open up the door to the bathroom and somebody is in there. So these are things that we want to talk about when we ask the homeowner, when we're doing that building check. The other things that we want to look for are, say, fires in the fireplaces, that we want to make sure that correct windows. We want to identify the thermal boundary. Very important, and maybe a little bit too out of the realm of our discussion today. So have any of you out there, and again, use your question panel, have any of you ever run a blower door test and run into anything strange, weird, or sort of worth sharing with the rest of us? A nice story that you have about, couldn't believe it that you wish you would have done a walk through the house before you started. We'll get back to those here. But let's next talk about preparing the building. So here I kind of have sort of three sort of major parts. One, closing all exterior windows, because remember, we're testing how airtight that house is, and of course the window is a hole in the shell, basically. So we want to make sure that that hole is shut tightly. We also want to open all interior doors, and sometimes you will have interior windows. So here we have our energy auditor opening up the interior doors, and the reason for that again is that those interior doors can actually shut off the outside or part of that house and we want to test all of the house. That one of the great things about a blower door test is that it tests the entire house, the entire shell at the same time. So, and here we have the auditor just turning off the furnace, turning off any interior fans, and just got a little story here from one of our friends out there. Thank you, Mr. Vega. That a damper was open on a fireplace with ash in it, and it went everywhere. One of the most common stories, there's probably two common stories that I think we've all, many of us have run into, or at least know somebody that, a friend of a friend type of thing, but is that this great story that Mr. Vega shared, thank you so much. The idea that there was ash in the fireplace, and you started to pressurize the house, and ash sucked in everywhere. I actually have a good friend who is, has been running blower doors since they were, since they were invented. I think Retrotec started right about 1980, 1983. This guy was running blower doors back then. And at one time there was a fire in the fireplace, and he said, "Oh, well, I'm not going to depressurize it. I'm going to pressurize it." And he blew so much fresh oxygen into that fireplace that he said the bricks were starting to burn red hot. So, and once there was a hole in a bedroom wall and behind a painting, and it was, he said, "I once found a hole in a wall in a bedroom behind a painting because the bedroom was a zone. The bedroom zone was very high." And he says that the owner said his wife made the hole with her head. That hopefully she was just, she was just like some kind of metal headbanger. It wasn't some kind of anything scary, but yeah. So it's very important that we have the outside doors and windows closed, the inside doors and windows open, the fireplace shut off, or sometimes, with the fireplace, if you want to make sure that you're testing that hole, because that is a hole in the shell and you want that to perform, you want to test it as it is. Sometimes I've known people that say just take a newspaper and get it wet and put it on the ashes, or any of those things. But yeah, make sure that furnace is turned off on the boiler, and so you don't pull any smoke. Thank you, Mr. Burroughs. Good point. But yeah, you want to make sure that furnace is off too. All right? Any questions about that? So the next thing is pretty basic. You want to install that door frame. So here I'm kind of giving a few details about our new frame. it clicks in. It's not like some of the the energy conservatory frame that's on the market. I think the one that's most widely used that has sort of these little metal buttons that you push in and you slip it in. This one actually has a metal, or I'm sorry, plastic caliper that slides into place. So this is what it looks like. You slide it in and it clicks in, and then when you want to take it out, you just push it down with your thumb and pull it out. You also want to make sure that you picking the door. Question for anybody out there. Oh, what about the water heater pilot? Great point. At this point, so now that I've done this walkthrough with this house, now that I got the house set up, I've actually done most of the work. And you do want to make sure that that water heater is set to pilot, or I'm sorry, is set to vacation or turned down, because sometimes you can suck a pilot light out when running a blower door. That will happen, and that can be just a nightmare, especially if it's if the house is if you got to crawl around on the floor and light those on. So, well, and then we have some notes about now, and I'm not going to get into some of the health and safety objections to actually testing a house. So, I'm sorry if I just got a note from someone that had really good insight about some of the possible health and safety issues that might prevent you from running a test. Definitely, you know, that's going to be, thank you, Mr. Alferis, that is definitely out of the range of this presentation, but you know, we definitely at Retrotec stand opposed to anything that hurts the homeowner or the house. We always say do no harm, and we definitely believe in that. And there are people that keep the frames together. They put them up, and it's easier and faster to get them in there. But again, the idea is that the most important thing is that you don't have any interference. That you put it in a door where it can easily move as much volume of air as possible. That's oftentimes, I know a lot of people who like to set the door up if it's especially cold when they're running it. Many times they'll like to set it up in the back of the house instead of the front of the house, because oftentimes the homeowner is in the front and it can make them very cold. Obviously, we just talked about the furnace being off. Make sure that it's in that door tightly. Not only can that give you an inaccurate reading, but it can also suck right out of the door frame and hit you in the head, which it's done to me. And I'm not too big of a man, not too proud of a man to admit it. Any questions about that? So after that, you're just going to install the system. This is what the installed system looks like. Had a question earlier about where's the best place to put the manometer. You'll notice that in this picture right here, we have the manometer sitting on a case off of the manometer case itself on top of the blower door case. However, if that's not your favorite place to put it, you can actually put it up. We do provide you with a place on the panel on the frame to hang it. And I'll show you a picture about that in a second. However, what you don't want to do is you don't want to have it anywhere around here. You don't want your manometer, your gauge, in front of the flow of air. Because that'll throw off your readings completely. So if you can't avoid that for whatever reason, and I have been in situations where I actually had to sort of put my gauge in the flow of air, you can add another tube to that and run it somewhere into the house where there isn't air flowing over it. Thank you, Mr. Wozniak. We will get to that. So the other thing about installing system is basically this is a point where you put the fan in the frame, in the panel, and then you connect all of your cords from the fan to your gauge and all of your tubes throughout the house. And this is what it will look like from the outside. And yes, you're right. Anybody else want to offer whether or not this picture is a do or a don't? Yes or no? Good. Is this a good setup or not? Yes, good setup. No, bad setup. Not one yes out of you. Thank you. All of you are exactly right. That is not a good idea. So we'll talk about that in a second too. So let's get into, if that's okay. So we've got the house set up. We've got our system set up. We've got it installed. Let's talk a little bit quickly about the DM32. let's specifically talk about sort of a really quick 3-step process of getting the DM32 ready to run a blower torque test. Is that all right with everybody? Okay. Well, step 1 is you want to confirm the device. So the way that the DM32 works, it's very simple. It's a touchscreen. We call it a smart gauge, because this screen, this user interface, is just a touchscreen, and it's very, very intuitive, the way that you would want technology to be intuitive, and that means intuitive in a way that's helpful, not confusing. So let's explain that. So I've got everything set up. I've turned on my gauge, and now here you go again for Mr. Sanfilippo, who asked where's the best place to put the gauge. You'll see in this particular application, I've actually hung the gauge on the frame because I actually like this the best, because then I can stand up and work the gauge. So we turn it on, and I want to make sure that I select the right device. So I tap here. And then I just choose from my selection of devices. So I mean, I can see the picture. I'm running a 1000 blower door, so I see the picture of the 1000, and I tap it. Simple as that. So that will give me the device. Additionally, now I just look at the picture here. I see what kind of range I have on there, what kind of range plugs I have. I look for that picture, and I touch it. Simple as that. And that's how you know that you've confirmed and set up the device correctly. Second step is that you might want to change results or units. Now, we did talk a little bit about people that might be running an ACH test, or which is an air changes per hour test, and some people that are running a CFM test, cubic feet per minute. So in here, all we're saying is similar to how we set up the device. We're actually just going to look at the results, and if they're not the results that we want, we simply tap them, and then tap the results that we do want to use, and then go back to the home screen. It's really that simple. So you're just going to be touching the screen. Whatever you want to change, you touch it. Simple as that. Let's move on to the third step, and that's where you can kind of do the time averaging, or any of these sort of settings where you're just looking to get it set up to run in the settings. That's the time averaging, and then you tap on time average, and you can use 5 seconds. That's especially helpful when you're doing when you're actually setting up a baseline. But once you've done that, then you can actually start the test. And when we're ready to start the test, here you'll see here's our guy starting the test. We just push set to pressure. We can actually set it to pressure that we want, say 50. We can actually set it to a percentage if we're doing a test and we're not curious about the results. We're just actually looking for leakage. We can just set it to a percent, say 10%, and just let that fan run at a percentage of speed. So whichever one we want, we can choose, and that's going to be available to us right now. So I do have a question about multi-point testing. Multi-point testing, we have software that you can run connected to our Wi-Fi gauge, and that software is going to be run from a PC, and you can actually run a multi-point test from that. However, this particular, your gauge will not run a multi-point test on its own. That'll be done by you manually. Okay. So let's talk a little bit about quality control and accuracy. So one of the big things that we're talking about when we're talking about quality control and we're talking about accuracy, we're talking about, yes, two different things, but they do kind of walk hand in hand. Quality control is the idea that we're testing what we think we're testing. Oftentimes that includes doing a third-party verification or inspections for other people, which I know that a few of you mentioned. We also talked a little bit about making sure that the tests that we run are not fallacious. Remember, keep in mind that some people already pointed out where the reference tube was. So that's kind of what we're going to talk about in this section. So I'll take a break. I'll take a second here see if we have any questions. So just we do have a comment. The comment or the question is, I guess this is a comment. in reference to multi-point testing, I understand that California now requires this multi-point testing. That's what I need to understand. Definitely join us. That's definitely a topic for another day. Specifically, we can talk about the R Cloud, which is a new online cloud-based testing and storage solution that'll be out soon. Or we can talk about Fantastic, which is an existing piece of software that we offer right now. Or we could talk about the data logger. Any one of those things. But I'm sorry, Mr. Matthews, we don't have the time right now to I'm sorry, that isn't the subject today, but we will talk about that later. And definitely go to Retrotec.com if you want to find out any information about that, because we do have plenty of information about that. So got a question here, or a point about putting the exterior hose in a bottle. We will talk about that in a second. And multi-point testing, more than one blower door. Yeah, and again, for the question about the multi-point testing for more than one blower door, that's a multi-fan test. We did a webinar about that last week. It's really good information. Colin Genge was actually on that, and that should be on our YouTube site in a week or two. So let's talk a little bit though about single fan, single point residential blower door testing. So the first thing that we want to know, as far as from a quality control perspective, from an accuracy perspective, is the first thing you're going to know is that when you actually buy a fan from Retrotec, when you buy a system from Retrotec, you're going to get the calibration certificate. Now, there's essentially two parts to this. There's a digital pressure gauge and test fans. They are calibrated separately. And then the fan calibration, the fan calibration must be verified every 4 years, according to some of the ResNet stuff and some of the other codes. But I'll tell you how we can figure that one out. So we'll get to that in a second. But basically, those are the things that it says on this calibration certificate, and this calibration certificate is going to be for your gauge, for your fan, and it's going to certify via our certification, our calibration chambers, that you are in compliance and that you are actually calibrated. So that's the first step to accuracy and quality control. The second step has to do with our DM32. Now, the great thing about the DM32 is the DM32 is being it's a Wi-Fi gauge, it's a digital gauge. It can be plugged into, what we're looking at here is a screenshot from our DM32 configurator software. So you plug that into your DM32, it's going to go online, make sure that your firmware is up to date, and it's going to say when it was calibrated. So you download that update, and that's a really easy, quick way to make sure that your gauge is up to date. And this is the current version 2.2, build 49. All right, so any of you have a DM32 in your hand, make sure that it's up to date. If not, plug it into that configurator, and that's a free piece of software available at Retrotec.com. All right, so back to really quickly about how we can make sure that we are in calibration. Now, I wanted to mention, I know there's some California folks out there who have noticed, and all of our software, unfortunately, is only PC compatible. We do not, it's not Mac compatible. If you do have a Mac and you do want to run it, you can actually use Parallels or one of those other ones. I'm really sorry about that. We do have plenty of people, Joe Medash and Colin, several people from Retrotec who actually use Mac and have segmented their hard drive so that they can run Windows 7 with one side or with the whole thing. But yeah, not Mac compatible. So let's talk a little bit about field calibration. We can field calibrate our fan or our gauge, and we definitely want to do that. In fact, sending it in for calibration is extremely expensive, and that's because these calibration chambers, like the one that I mentioned that we have at Retrotec, can be well over $500,000 at least, especially if you have a nice one. So the actual testing itself, the calibration that we do is intended for new products. So when you send in a product that needs to be calibrated, it usually costs a fair bit of money. But it doesn't always need that. It doesn't need to be calibrated. And here's how we know. So with the fan Oh, and I'm sorry, I should mention that, and all of this information, and this is actually a picture from the quick guide, from the blower door quick guide, and this is all this is explained again in the quick guide. So let's just go through it really quick. Here it is. So with the gauge itself, very easy to field check. You want to do this with the tubing that you use in the field, and you want to do this with your DM32. Can be used, actually you can do this with your DM2, you can do this with the DG700 from the Energy Conservatory. It's up to you. But it's a very simple test. So let's talk really quickly about some of those resonant codes. So many people, some of these people, or many people have mentioned to me, yeah, well, ResNet says that, that I have to get my stuff calibrated every 2 years. Well, technically what the ResNet code says is that it has to be proven to be in calibration. So it doesn't have to be calibrated per se, and this is a way to prove that it's in calibration. And it's very simple. You have two different channels that are essentially two completely separate manometers, right? This one references this one. This is the reference, input reference. Okay, so the only thing that connects these two manometers, one gauge but two manometers, the only thing that really actually connects those two is power. Other than that, no pressure readings are shared. Okay, so what you're seeing in this image is just taking one of my tubes, plugging it into one channel and into the other channel, and then you'll see I've got both channels set for pressure, and I'm getting the exact same number. So the pressure that when I actually push this tube onto the tap, it pushes pressure into the tube, and that pressure should be shared. So I should be getting the same reading from both sides. And then all I've done is basically moved that tube to this tap and that tube. And the other end of this tube, this is the same tube, and kind of repeated this test over and over with all my different tubes. So that's simple as that. The point is that because these are two completely independent manometers, you should get the same number, and it will not be a coincidence. It's not some bleed over. So it should be within about 2% of each other. If not, then you actually are out of calibration, and you do need to have your gauge calibrated. If that makes sense to everybody, let's kind of move on to the next one. Again, this is how we interpret it. We can also do a quick field calibration for our fans. This one is a little bit more involved, but again, we do have more training about this, and you will see you'll see this this actual excerpt from a quick guide that you can find online for free. And basically what it's explaining is that what we do is take any room. Usually it's great to do a smaller room that's inside the house, simply because of the fact that it's easier to control, and you don't have to worry about too much. Again, we're not doing a test of the shell here, we're just calibrating the fan. And then, so what we'll do is we've got all this equipment right here, and all of this stuff comes in, this is your blower door system, and this is a piece that we've made. Now here I have a wooden board that I've used, but you can use a piece of cardboard, you could even use a really durable piece of paper or corrugated plastic, anything, just as long as it's flat. And then what we want to do is we cut a hole into this plain, this rigid piece of material, and we know exactly how big that hole is. So what we're going to do is go on to our gauge, set our gauge to give us EQLA per square inch, or equivalent leakage per square inch. Now, for those of you who are not in the U.S., we do also have metrics, so you could do per square centimeter, or I guess centimeter, right? So it doesn't have to necessarily be this, but this one is set for empirical guys like myself. So then what we do is we kind of set this door up. So now we put our fan into the door, and we put this piece that we made above it. So what we're going to do is we're going to run the test once with this hole covered and see what our EQLA is, or our equivalent leakage per square inch. So once we get that, then we'll actually uncover this hole, and let's say that this hole is 12 by 12. We know that is 144 square inches. So this time, when we run the test on the room, we should have the same. We should have an EQLA of the original test plus the 144 square inches. Hopefully that makes sense to you. Any questions about that? So I did have a question. Did you say the online training is free? The online training is free for people who have bought the equipment. It can, depending on who you are and what your applications are and what training you're talking about. I couldn't begin to tell you exactly what the price is. I know it's very nominal, but again, if you have any questions about the price, or if you apply for it, or even if you think you might be able to sweet talk somebody into a good deal, I'm not saying, but I'm saying, call this number. You can ask for Scott or Mario, or just send an email to sales@retrotec.com. They'll be the ones that actually can tell you a little bit more about that. All right. So if there's no questions, let's talk a little bit about common problems and solutions. So I did have a couple comments. I was not ignoring them earlier. One about putting the tube in the bottle, and another one about people that many of you noticed that the actual reference tube was set up incorrectly in one of our slides. So I want to talk a little bit about that if I can. So yes, very, very important to understand. I've already asked this question, so sorry about that. Is this okay? And absolutely, positively, this is not okay. So let me explain really quickly. The way that a manometer works, the way that our gauge works, is it has two channels. Each one of those channels are going to tell you our referential pressure gauge. Easy for me to say. It's a referential pressure gauge. That means that what the results that you're getting are the difference between 2 points. And that's going to be, in a blower door test, it's going to be the pressure inside the house in reference to the pressure on the reference tube. Now, this particular reference tube is right in the blast of air from the fan. Many of you noticed that originally, and you were absolutely right. That can cause all kinds of turbulence and all kinds of felonious, or maybe I should just say mistaken readings and results. So what's the answer to that? Here's a best practice that I came up with. So somebody asked about a bottle. Now here, you want to ruffle some experienced testers' feathers. I'll then mention this to them. Ask them, did they use a bottle? Now I know some guys who have done hundreds of tests, many more tests than I have. I know, and they will swear up and down that you can just stick the reference tube, this red reference tube, into a Coke bottle, or that you can stick it into a manometer bag. I say no way. One, because I've experienced this many times before, and two, because think about this. If you're in a brick house, I have actually done a test where we're testing the pressure in a combustion safety zone in a basement that is mostly subgrade of a brick house. And on a windy day, we can get a positive pressure on the windward side and a negative pressure on the leeward side. I messed that up. We can get a negative pressure on the windward side because the air is being pushed through the wall and out that door, causing a negative pressure in the CAS zone. But on the leeward side, where air is being pushed into that, we can actually get a negative pressure. So the idea that a little cloth case can protect a reference hose better than a brick house just doesn't make any sense. So this is what I recommend. I've been doing this for a while. I actually just take a tennis ball, perforate it. I put a little attachment in here. This is just an old, this is a rubber straw that I use. It fits, the tube fits perfectly in there, but you can just use an adapter or a coupling. And I used to take it, I used to dig a little hole and put this blower or this tennis ball in there and then just leave it. But then a friend of mine said, well, why don't you just make a hole? Why don't you just take some dirt and some rocks and put it into this container, and then you don't even have to dig a hole. Now you've got a portable hole with you. So I use this all the time. If I see you, again, my name's Jay West. If you see me at a show, or if we're out doing some demonstrations, come on by and I'll show you this. I actually stick this right inside of the house simulator, which is a very small testing and demonstration house, and stick it right in front of the fan, and we'll watch the readings just absolutely hold steady. All right. Question here, what percent fan speed is the best for the test? So I guess there's a couple ways of answering that, but the main thing is that it's not the percent of fan speed that you want to use for the test. You want to be testing to a pressure. Now, if your fan is going at 100% fan speed and you're still not getting any readings, that means that you need to open up that fan a little bit more, and that means take one of the range rings or plugs off. But that's a very good question, but a little bit more advanced than what we're kind of talking about today. So let's kind of move on. If anybody has any questions or comments. Okay. So just to let you know, we aren't going to talk about this too much today. There were some questions about it, so we're going to have a few minutes here at the end too to open up for questions if you have any questions about it. But I do want to make you aware of the fact that we do have plenty of software. The majority of it is free software. We have mobile apps. We have PC software that is intended to be extremely helpful to help you to work smarter, work faster, and work better. This one is particularly interesting. This is called Virtual Gauge. You can download this. This is a PC application. You can download this from Retrotec.com for free, and you can use it to run an actual gauge, or you can do it to actually simulate a gauge. So when I first was hired by Retrotec, or when I was first got the contract for Retrotec, I didn't have one of their gauges for myself. I used to use it with the agency that I used to work for, but I wanted to learn the new DM32. So what I did was downloaded this, and same idea. I could push buttons and run this virtual gauge exactly the same way as you would run a DM32. So this is a really great opportunity to get to know this product, decide if you like it or not, for free. But the other application for this is I can actually connect this via Wi-Fi or via a hard cable to a real gauge and run it. And for those of you who've run blower doors before, especially those of you who have done combustion safety testing, or those of you who have done some air sealing while you're running a blower door, I'm sure you know how helpful that can be. All right. So that is here's a little bit more about that the gauge simulation. Here's some other ideas of how that can be used to run multiple different gauges, not just one. And then, of course, we do have mobile applications that you can use on your cell phone, Android, or Mac, or even Windows phone, tablet, or any mobile device to link up to our Wi-Fi gauge and to run that for any number of applications while you're in a different part of the house, if you're moving back and forth trying to guess or test pressure, or even if you want to sort of show a homeowner or boss or quality control inspector or even a building inspector what you're doing and how you're doing. So we've got so that's about it for our regular webinar. Are there any questions that I missed? Are there any additional questions, anything that you want to talk about? Please let me know. Send them in via our question, and I'll stop and just answer some questions. The free app. So we have the question here is, what is the name of the free app? So that is called Gauge Remote. Gauge Remote can be found on the Apple Store, or it can be found in the Android market, and can also be found in the Windows Store. That's Gauge Remote, and that is for remotely running your gauge. If you're looking for the PC app, that's called Virtual Gauge. Virtual Gauge is found at Retrotec.com. And you're welcome. Thank you for thanking me. Any other questions? What do you guys got going this weekend? Thank you. All right. Well, again, all this information, and as always, I just want to say thank you so much for spending this time with us. You know, we always try to do our best to provide you with useful information so that it is time well spent, not wasted. We take it very, very seriously, not only the design and the delivery of all of our products and services, but we also take very seriously your time. We know that your time is your money and it's your life. So thank you so much for spending an hour with us discussing this. I'll stay on the line here for a few more minutes until about 2 o'clock if anything comes to mind that you didn't think of before, and send you guys some rain out there, and Mr. Spindler. And then for those of you who are going to be in Providence, I will be at the JLC Live tomorrow, rest of the week. Seattle later this month for the Passive House Conference. Keep an eye out for Joe Medosh, who is in Dallas right now at the ACA convention, and maybe see you at the B4 conference or the Best 4 conference in Kansas City this April. All right. Well, thanks a lot. Appreciate your time, attention. Have a great day, everybody.